So we will just get you oriented this week, and then you can ask any question you like, because that's why we're here. And we'll document our questions here. You have exam 1 this week. That's your principal mission. So remember, after you submit your XYZ homework and written homework by Tuesday at 11:59, then I will have exam 1 posted by that time, Tuesday, October 27, and you have 48 hours to complete that exam. You submit it to our assignments folder, just like you submit your written homework. Thursday, October 29. This is the only deadline we have in this course that's not Tuesday at 11:59. So I'm trying to keep everything very uniform. Let me show you where you're going to find the exam on our website. So I'm going to share a screen with you. Let's go over to our website. And we're looking at our web page for this week. So this is week 9. This week you're going to take exam 1, submit your written homework 7 by Tuesday 11:59. Exam 1 will be released Tuesday, just what we said. Submit it back to the assignments folder by 11:59 Thursday, October 29. And it's going to be several pages long because I wanted to give you space to work. It would probably simplify your work a lot if you could print this out, and you can print it out at an office supply store, just take a USB disk in there. You could print it out at Delta College. You could print it out at a friend's house. I don't mind how you do that, but it would save you time writing, because I definitely have a cover page with the rules for the exam that I'm about to show you. And I want you to sign and return that cover page with the exam. If you don't have access to a printer entirely, you can write out that cover page, but that cover page is part of the exam. Just so I keep everybody under the same conditions, and so I can justify what we're doing if people or other schools ask me about the conditions of transferring this course. Let's go into week 9. I'll show you where you're going to see the exam. So here we are. I'll have the exam released right here. Currently, I have the cover page. Exam 1 covers through the first 4 chapters, and you submit it right here, just like you submit homework. If you want to let's just scan the cover page, read through it so you know what the conditions are. So here's a cover page. I can blow it up slightly for you. So this exam consists of 5 problems. I'm pretty sure. I'm just scanning my paper to make sure that that's what I did. Oh, where did I put that? I think I have 5 problems on the exam. And when you look at them, and then I'll start answering your questions. So throw them in the chat, absolutely. When you look at them, you're going to look at them and say, that looks like 5 of the written homework problems. I mean, they're going to look very much like that. They'll be a little bit different. But you're going to recognize them as similar to some of the written homework problems, or similar to some of the problems in the book. They're not going to be like the online homework, just fill in a blank, multiple choice, anything like that. Homework 7 consists of what? Let's look at homework 7 to answer Austin's question in a second. But you can look up whether that's in chapter 5 or not based on the sections we covered. Let's look at it in a second. So put your PDF document together, one document. You can have multiple pages. If you need help assembling that, let me know. Show all the work you need to reach your answers, not just the answers. I know the answers already. I can find the answers lots of places. I want you to show me how to do it. You have to complete the exam entirely by yourself. You can use your own book or notes. You can use any material from our website, previous problems and such. You can use Calculator or Desmos to check your graphs, but all the graphs on the exam must be drawn by your hand with complete scale, labeled axes, and perfectly neat. If you want to know what the graph should look like, open your book, look at their graphs. That's what your graph should look like. You cannot share any of the exam questions with any other person or service, and you cannot discuss any part of this exam with anyone else till it's graded and returned to you. Naturally, if we were in the classroom, you might ask a question about the exam, like, oh, did you mean this to be minus 10 or plus 10? I'm not sure if this is right. And then I have to look at it and say, you're right, it should be minus 10. Or no, it's plus 10. Keep going. So you absolutely are allowed to ask any questions you want about the exam. I don't have to answer them, like tell you how to do it, but I want to make sure you ask a question if there's something unclear or something that you think is wrong on the exam. Get some more people in the room here. Got it. So those are the conditions. I'd like you to sign that you followed them and return this cover sheet with the exam to me. There's going to be 5 problems on the exam. Whether that takes up 4 more pages or 5 more pages, I wanted to give you room to work if you printed it. I haven't formatted that exactly yet. Okay, one final thing on the exam. So let's go back to our website. And that is, excuse me, back to website. Make sure that you name the exam properly. So last name, first name, exam 1, math 121, and your section number, either FA 810 or FA 830. Okay, now you can unmute, you can ask questions. I'll check Austin's 2 questions right here, but just for a few minutes, any questions you want to ask about the format or the conditions of the exams. Let's look up homework 7 so we know exactly where that was coming from. I'm on my web page. I'm in homework 7. I have to remember what that is myself. Let's admit someone else to the room. Okay. Homework 7, we're looking at identities, and we're looking at the sum and difference identities. So I'm gonna pull my book off the shelf and find out exactly where those were from. The sum and difference formulas were from section 5.2, and the identity problem here is from section 5.1. So these problems are not exam questions. They are in the next exam. So let me go back to my website so I can illustrate that better. I keep going back to my website by closing that window. That doesn't make sense. Right. So last week, we were doing section 4.6, inverse trigonometric functions. Then we opened up 5.1 and 5.2, which is proving identities and sum and difference formulas. So those are not acceptable on exam 1, just through the end of chapter 4. Okay, so I hope that answers that question. You still have to do it and submit it by Tuesday, because we talked about those problems last week. Is there any other question you want to voice or type about the format or the conditions of the exam? Okay, no problem. So now to what we're going to do today. We're here in week 9. I have no new material, absolutely no new material. We'll pick up again next week. I'm just going to answer the questions that you asked right now, and then I'll take these written notes and post them online, and I will post the video online that we're recording in case someone's consuming it later. A couple of people watch the videos afterwards because they have other commitments. So the floor is open. I'm going to sit here and clean papers and rearrange my desk. But whatever question you ask, that's what we'll do. Yes, Austin, I generally remember that. And Katoria, then we'll pick out a question just like you asked. Can you just remind me, Austin, roughly what question you had asked? Because I remember you said something and I said, oh, that's good. We'll save it for a review session. I am scanning my email. No, I see a question from you a while ago, but this was a question you asked inside the XYZ homework, I think. And I can go inside the XYZ homework and look it up. But if you, okay, thank you, do that. And then we'll get to that question. So Katori is asking about, if I have a picture, can I identify the graph? And for that, I'm gonna have to go to the XYZ homework. So let's open that up. I mean, it'll just be easier if I show it to you on the screen. It's a very good question. And it's coming from section 414243. And you had a recent homework that was like that. So I'm going to look at, I'll show you a couple problems. Whoops, XYZ homework doesn't like me right now. Let's figure out what's going on. Somehow my login failed. Okay, I'm back to the paper. I'm back to the login screen. And logging in. We're looking at that, and we're looking at trigonometry, and we're looking at the book. I want to show you the pictures in 5.2. I'm sorry, 4.2. So I have to log into the book. Thankfully, it's the same login, but it would be nice if you just logged in once. Okay, we're making progress. 4, 2, and I'll share the screen with you. and I'll put away the videos. So the idea here is if you have an equation in red, you should be able to draw the graph. But if I show you the graph, you should be able to find the equation too. So he's got some problems like this in 4.1 and 4.2. Let me show you some in 4.1. Let's warm up on one of these. So here's a whole handful, 43, 44, 45, 46. So let's take it, straight from the top. Those are 4 very good problems. So this is exercise 43 in section 4.1. And I should draw that nicely and then you should do it, but I just want you to just expand it on your screen here. Trouble is I don't want to draw it and say it and do it. So here's what I'm looking at in 43, and I think he's trying to be your friend by coloring part of it. But the basic idea in 43 I want to see if I can share the book and share the screen at the same time. Something makes me say that that's not going to work, but let's see if I can do that. Okay. Here's the compromise we'll make. I'm sharing my screen, but you can see my hand and my paper. You can expand that, go back and forth between the screen if you like. So what I have right here is a graph in 43 that has a period of 2 units. That's the box is 2 units wide when I repeat. I start repeating, I start at 0, I stop at 2, and then I start repeating again. It's got an amplitude of 2. And it's a basic sine graph. Seems to be starting at 0, though you could call it a cosine graph too. So let's take a look at your basic sine or cosine graph. Before I shift it left, right, up, or down, remember these numbers right here. This A is the amplitude. And if A is positive or negative, that just talks about the graph being right side up or upside down. And the B right here, it determines the period. It's not equal to the period. It determines the period. How does it determine the period? 2 pi divided by B is the period. So if I want an amplitude of 2 units, I'm going to put 2 in place of that A. And if I want a period of 2 units, then I want to know what B is going to make 2 pi over B equal to 2. I have to solve this for the absolute value of B. Now, I'll just take B to be a positive number, but if I multiply by B and divide by 2, that means that B is equal to pi. And so this function right here produces that graph that you see in 43. Now I could also think about phase shift, and I could think of 43 as a cosine graph that's being started, remember this is symmetrical, being started at 1/2. And the phase shift is determined by this. when you have a graph A sine bx plus c, the phase shift, it's not the c, but it's the number you get when you set this equal to 0. It is the starting place of your sine or cosine graph. So if I want the starting place to be 1/2, if I want minus c over b to be 1/2, and I know b is equal to pi in this graph, then what does c equal to? Minus c over pi is 1/2. So I multiply both sides by pi. Minus c is pi over 2. And that makes c minus pi over 2. So this graph could be a sine or cosine graph. It could be a cosine graph that starts at minus, at 1/2 if I insert c equals minus pi over 2. Another way to look at that is to say, if you factored out the pi inside the argument, what would you be left with? X minus 1/2. That's another indication that the starting place is at 1/2. So let me take these two drawings over to Desmos and see if I don't match what is in the book. Just graphing. Here's y equals 2 sine of pi x. You get a pi in Desmos just by typing pi. And if I zoom in on that, let's make it look exactly like the book. Here's the book. -3 to 3, -2 to 2. Let's get a window that kind of looks like that in Desmos. I'll take the x-axis to be -3 to 3. I'll take the y-axis a little bit larger to be 4 to 4. And that graph looks almost exactly like it shows up in the book. Maybe I can make those letters a bit larger. Go projector mode. Okay. So now I could also have the x-axis mark every single unit. Now that adds these extra grid lines. Let me check out, take out the minor grid lines. I could take out the grid completely, and that looks a little bit more like the book here. Okay, but look at these nice smooth curve, perfectly regular and repeated, and axes labels marked according to the period and according to the height. If the period's based on 1, 2, and 3, if the period's 2, then mark your axes in 1, 2, and 3. Mark your axes in whole number units. If the period's based on pi, then mark your axes in terms of pi. Okay, let's go back and type in the cosine graph that I also said worked. Y equals 2 cosine pi x minus pi over 2. Oops, I just type pi lowercase pi. Don't type uppercase pi. And look at that. It's exactly on top of the graph that I just did a second ago. So that's exactly the same graph. In Desmos, you can make one line dotted and one line whole. It doesn't show up super duper on this picture, but it's fair. Let's try another one. Here's a cosine graph. the piece that he's showing you in red, cosine graph upside down, starting at 0, period 2 pi. So if I wanted to graph something like that, I graph an ordinary cosine graph. Period 2 pi means the b right here is just a 1, but it's upside down and it has an amplitude of 2. It hasn't been lifted up or down, but it's centered, still centered on the x-axis, but amplitude 2 upside down. So I will multiply by 2. That's a cosine curve right side up. Multiply by -2. Now it's a cosine curve upside down. Do you see the scale on my axes is all screwed up? Because what do we want in this picture? Marking by pi. So that's what you're going to do on your paper. I can show that to you here just by telling Desmos to mark the units by pi. Let's mark them by pi over 2 to get a few more. We wanted amplitude 2, so let's mark the amplitude in terms of 2 units there. Turn on the grid. This looks pretty much exactly like the figure in the book. If I go from -2 pi to 4 pi, that'll nail it. So x-axis -2 pi to 4 pi. I could just as well do this in the calculator, and maybe I should also do this in the calculator. Now that graph looks exactly like the graph in the book. Okay, different color, different perspective, but going through exactly the same points, peaking at pi and 3 pi, at the bottom at 0 and 2 pi. Peaking at pi and 3 pi, the bottom at 0 and 2 pi. Amplitude 2, centered on the x-axis. You could also do this on the calculator, and maybe we should do an example on the calculator. Let me turn this into a sine graph. What would this be if it was a sine graph? It would be like a sine graph that started late. Started at pi over 2, but has an amplitude of 2. I could say 2 sine ordinary period of 2 pi, so the number in front of the x is still 1, but I have to move it over pi over 2 units. Then it lands immediately on that graph, exactly on that graph. If I use the dotted format, you can see both graphs at once. On the homework that you most recently did, that's when I gave you a problem or a picture or a recent homework where you had to take one curve and write it as both a sine and cosine graph. Before I go, because I consider this question to be that important, before I go over to Austin's question, which was also very good, I'm looking for a problem in 4-4. One more like Katori asked, because I think these are really important problems. Let me do this problem in your book. It's 4-4-24. Let's do problem 4-4-24, but this time I'm going to do it entirely on the paper, so you can see the picture and the work at the same time. Thank you for being patient, Austin. Then I'll get to your question, which is also from 4-4. So I'm going to turn off the screen sharing and go back to my paper. Now I'm going to draw what he drew in the book. Trying to decide whether I like this or not. You know, I like 21 better. I like problem 21 better. So let me draw problem 21 for you. It looks like a sine wave. It looks like it's upside down. It's starting at 0 and 2. It seems to go as high as 6 and as low as -2. So I like to do this problem also because it has a vertical shift in it, and because it's good practice for drawing. Let's mark. It seems that a whole period takes 2 units. So let's mark 2 units here. But notice I did it in 12 boxes. I posted a handout on the website showing you how to cut a period up into 12 boxes, 4 boxes of 3 boxes each. So let's draw this really, really neatly. And answer the question. So this will be 2, this will be 1. If I was to continue, this would be 3. 3 boxes, 3 boxes more, this would be 4. Let me get out a different color here. So this graph starts at 0, 2, ends at 2, 2. Right in the middle, it's at 1, 2. It's a sine graph that's upside down. So, but when you're at 1/2, it goes down to -2. And when you're at 1.5, it goes up to 6. This is actually 1/2 and 1.5 and 2.5 and 3.5. Just to be clear on those. Now, this is an upside down sine graph, no problem. Period 2. Amplitude is deviation from the center. So this goes up plus or minus 4 from the center point, from the center line. Amplitude is 4. It's starting right at 0, but it is upside down. So it has no phase shift. It starts right at x equals 0, but it does have a vertical shift. Everything has been lifted up to. Let's make a really nice picture of this. How do we use the 12 box method? I go over 3 boxes to reach the peak. So the first third, I go halfway up. And the second third, essentially on my paper, I go half, half, and half again. So not exactly in that dot, but very close to that dot. I'm marking these points. This is exactly the way I want you to mark your points. And then we'll draw this picture. Just gently shade this in. And then it doesn't matter if you're not a super straight drawer, but you gently shade this in and then you make it darker. Trace over it. Okay, that is exactly what the picture looks like in the book. Now, how do I fit that into a sine curve? with all 4 pieces. Horizontal and vertical, scaling, stretching or shrinking. And then right here, horizontal, and vertical, shifting, that's moving it up, down, left, or right. Okay. Let's check out the scalings first. This is amplitude 4, but it's upside down. So I write -4 sine. Now I want a period of 2, and that must be 2 pi divided by the absolute value of b. I'll just choose to make b positive. So how do I turn 2 pi into 2? I have to divide by pi. B has to be equal to pi here. I'm starting this at x equals 0. We'll deal with that in a second. But the d is moving this graph up or down. So if I have a vertical shift of +2, if I raise this graph 2, then this has got to be 2 right here. How do I find out my starting place? How do I find out what the value of c is? Well, I want to subtract 0 from x. If I think of this being written as pi times x minus phase shift, what do I want to subtract from 0 if I'm starting at x equals 0? My starting place is 0, so when I multiply this out, it'll be pi x minus nothing, pi x plus nothing. So in this problem, the c is 0. And this is the full graph. Now this time, let's put it into the calculator so you can still see my paper and see the equation at the same time. And the only downside of that is that the calculator doesn't draw really nice marks on the screen. Let's see if I can get this all together at once, but I'll bring my calculator closer to the screen. So let me clear this stuff. Remember, drawing graph, I'm talking about being in radians. So I make sure I'm in radians first. And I can enter this equation that I found, -4. I don't say subtract. I use the minus key on the bottom of the screen, not the subtraction key. This is -4, not subtract 4. Times sine of pi times x. You can type in the pi just like you see it. I don't have to say pi x minus 0. I'll just say pi times x plus 2. Now before I type go, let's make sure it looks like this picture. So my vertical scale, let's run this from like -4 to 8. Let's run this window vertically from -4 to 8. And let's count by 2s. Sorry, that's going to be an 8. What about horizontally to make it look like my drawing? I'm going to run it, how about from, let's start at 0. Although I usually like to show stuff on the left, but let's go 0 to 4. And let's make a mark every 1/2. 0 to 4, making a mark every 0.5. So on my screen, I'm going to see 2 periods. And I have the dots turned on my screen. Whether you have black and white Or color screen, you can have the dots turned on. You don't see them here too well, do you, in this image? Let me see if I brought the calculator closer to the screen. Would you see the little grid dots? The grid dots are kind of reassuring to look at. You do kind of see the grid dots sitting right here. I think I will try that. You do that with a format key right here, second function format. I think I will turn it to grid lines, which you don't have on the black and white calculator. But these grid lines show up a little bit better. Now this looks a little bit more like my paper, except my paper has a lot more grid lines. The only thing I don't like about this picture right here is I usually like to see both axes on my screen. Here's the y-axis, but I'd like to see a little bit to the left of the y-axis too. So why don't I run this puppy backwards 1/2? And what would that mean for my picture? I'd have to get up here to height 6 again, and halfway by the first third, half, half, half by the second third. Nice round graph like that. So if I change my window, I don't know if I can get this all on at once. It's a little bit too tight. How about that? If I change my window, but then I got this glare, I'll get rid of the glare. If I change my window to be x equals minus 1/2, then let's graph that. And let's remove the glare by holding something between my calculator and the light. That's perfect. Now my hand drawing, I only went 1 period. So this right here, this is the part where I need 3 hands. This right here must be the value 2 that I'm pointing at with my pen. I can almost write a 2 on the calculator screen. I hope it comes off. But that's how I do something with a vertical shift. Excuse me while I wipe that off. Okay. Okay, so I really think graphing is important. I want you to graph perfect graphs. And this is a perfect graph. Well, I forgot one thing. Name the axes. But other than that, this is a perfect graph. And your graphs have to look exactly like this. And it's not impossible to do either. You'll say, well, I can't draw like that. No, I didn't draw anything. I just made dots in nice places and then followed the dots. Before I go and answer Austin's question, oh, and here's a quick one. Why do I have point +2 at the end of the problem? The book had it in front. That is true. Some people prefer to write the 2 in front. I'll tell you why I put it in the back, but there's nothing wrong with putting it in the front or back as long as you use parentheses here. I tend to put it in the back because first I want to scale things, stretch, shrink, up and down. I want to make things stretched vertically or shrunk vertically, and then stretched horizontally or shrunk horizontally. And then I will lift the graph up or down with a D and left or right with a C. So I always say to myself, this is a good policy to follow. Scale before shift. And in that sense, that's why I wrote the C and D in the back. Now, some people get nervous when you write a number on the back because they're thinking, did he mean to add 2 to pi x? Or did he mean to add 2 to sine of pi x? And that's why I use parentheses. This is entirely different than that. The location of the parentheses makes a critical difference. This has a vertical shift, up or down by 2. This has a horizontal shift, phase shift, if you solve for x. Sorry. That phase shift would be pi x equals -2, x equals -2 over pi. That would be a crazy phase shift. So what he wants is people should never write something like this, sine pi x plus 2. Because when you write like this, then your audience is saying, which way does he want it? Does he want to add the 2 after doing the sine, or does he want to add the 2 and then do the sine? So as long as I use parentheses clearly around the argument of sine, around the thing I'm taking the sine of, it's okay to put it in the back like that. But you are right. A lot of times the book will put this number in the very front. And I think from a safety perspective, that's not a bad idea. But I want to go back to how I want to be very hardcore about these dots, these 12 dots. How did you draw such a beautiful smooth curve? I didn't. I just put down these 12 dots and then followed the dots. 12 dots in each period. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then starting dot, you could say 13. But after reading your past homework, I saw people had a question about putting down exactly the right dots. So let me show you this on the website. I made a handout so you can look at that. We're in week 9. Handout right here called the 12 by 4 box method. So on this handout, I wrote, well, I can't get it all on the same screen at the same time. It's a piece of paper. But I wrote my box that's 12 units wide by 4 units tall and showed you how to put each one of these dots in perspective. At the middle point, at the higher low point, at the half point, or half and half and half again. That's where I put these nearly highest points or nearly lowest points. Think of my interval from 0 to 2 pi as being chopped up by various fractions. Now this is, if you say half, half, and half, that's not exactly perfect, but it's within 1% of perfect in that drawing. And so that's very hard for anybody to touch. Nobody can really criticize you if you draw those dots so nicely and smoothly like that. Okay, back to the chapter 4 XYZ question. So personal preference, Austin says, yes, that is correct. It is personal preference. You would not get marked down as long as you put the parentheses in the right place. So in this problem, always, and so it's you very casually, you do often write just sine x. But if you want to be safe, it's always safe to wrap the x in parentheses. That's like the safest way to write it. The x right here is called the argument of sine. That's just an old-fashioned word for saying, that's what I'm doing the sine to. That's what I'm taking the sine of. So you want to be safe. Always wrap your argument in parentheses. That one I don't want. Okay. Now, Austin patiently asked the question. Let's go to the 4-4-XYZ homework. And you are giving me a screenshot. Let's open it up. See what you got, and I'll share it with everybody. Okay, this is a really good question. And I answered you and said, oh, bring that up when we do a review. So this is what I wanted you to do. Thank you. Let me show this picture to everyone. And then we'll find the equation of that graph. So this is from XYZ homework problem you were doing, and someone said, write this as a cosine graph. And I'll expand this picture so you can see it better. Write this as a cosine graph. This is a serious one. This is not a simple one, but I'll show you where to go with it. I can think of it as a cosine graph that starts nearly in the middle. Right here, starts way over here, and I've yet to determine this line. But I don't get to do a whole period, right? So that would be a cosine graph that was right side up. Let's take this whole period upside down from here to here. Now let's look at where it started. It started on this third line, and the fourth line says pi over 2. So that means I should be able to figure out what each one of these vertical lines represents. And I'll draw it on my paper. But let's mark. You can pop back to my paper if you like, but as soon as I get this drawing down, I will switch to my paper so we can see what we're working on. It does 4 boxes and calls that pi over 2. Then it does another 4 boxes and calls that pi. Then it does another 4 boxes and calls that 3 pi over 2. And then it goes off screen, but the next one would be 2 pi. It varies, it looks like, from -3 vertically to 3. So it is still centered on the x-axis. But let's mark from, sorry, I'm throwing my pens around. -3 on the y-axis to 3 on the y-axis. And let's put a dot where he put a dot on the third line past the origin, right there. And then he completed one period on the third line past pi. I'm trying to make my beautiful dots. That means on the third line past pi over 2, or just one line before pi, he was as high as 3. And that means in the middle, between the high and low dot, I should be at 0. I'm trying to draw a picture just like his. Notice on the first line, he put the value 0. Second line, third line, just after 3 pi over 2, he has the value 0. So here's some more points. I'll go over 2 and up again. That's the place that he didn't reach. Now I can put my third points in, half and half of a half of a half, just about like that. A third of the way between the 2 points here. I'm just placing these points in here. And then let's draw this cosine wave. Now I'll draw the rest of it in a second, but let's go back to our paper now. So this is the picture Austin shared. I've copied it now almost completely to our paper. Okay, let's talk about the period. 1 box short of pi over 2. 1 box short of 3 pi over 2. It looks like that is 1 pi long. You see that? If every 8 boxes is pi in their picture, notice I cover 1, 2, 3, 4, 5, 6, 7. Sorry, 1, 2, 3, 4, 5, 6, 7, 8 boxes this way. So period pi, amplitude, three. I did not raise it up or down. Vertical shift, 0, plus 0, minus 0, doesn't matter. But I have got a horizontal shift. Where am I starting this? And then don't forget that it's upside down. Where am I starting this? Now I got to figure out what these marks mean. If this mark is pi over 2, then half of that is pi over 4. That makes this mark, this is going to get a little crowded, pi over 8. 1/2 of pi over 4 is pi over 8. And that's pi over 4, 2 pi over 8. That makes this mark 3 pi over 8. So I am starting at the phase shift is 3 pi over 8. Now I'm going to plug in to my formula. The other reason I like to put the D on the end is because it's the 4th letter in the alphabet. But we'll manage. So how am I going to find this equation? Okay, vertical shift, up, down, 0. I don't need to write 0 plus, but we'll just not write that next time. Amplitude 3, but it's upside down. So this is a -3. A is a -3. I don't need to write plus -3, but again, I'll just write -3 next time. Cosine. Now, what's the B? If the period is pi, where should I do this work? If the period is pi, that means 2 pi divided by the absolute B. Value of B is pi. So what did I divide by to turn 2 pi into pi? I divided by 2. So that is 2 right there. Now, how do I do the starting place at 3 pi over 8? It's not convenient to write bx plus c like this. It'd be rather easier if I wrote in the parentheses here, -3 pi over 8. That will give me the graph that starts at 3 pi over 8. I need the parentheses around that x minus 3 pi over 8. That gives me the graph that starts at 3 pi over 8. If I want to see it multiplied out, I could write 2x. I could multiply out the 2 minus 3 pi over 4. Now if I solve that for 0, I get x equals 3 pi over 8. Let's write it really neatly. Sorry, I should have raised my paper. And let's stick that in my calculator and see if I don't get the same graph. And remember, the only thing I don't like about the calculator is it won't label these. So I'm going to have to make a note that I want every mark to be pi over 8. So back to calculator screen. Let's type in the formula, then I'll go back and compare it to my picture. -3 cosine 2x minus 3 pi over 4. Or I could say 2 times the quantity, x minus 3 pi over 8. So 2x minus 3 pi divided by 4. Okay, that's what I wrote on my paper, just double checking. Yes. Now let's do the scale in this picture. And I'll get rid of that glare on the screen by tilting my calculator a little bit. So what do I want? I'll bring it closer to the screen a second for my window. Y between -3 and 3, that would fill up the whole window. So let's be a little bit more generous on the calculator screen and say -6 to 6. I just want it to be centered on the screen nicely. And let's make every mark worth 1 step. Y scale 1. Let's go back and do the X. Now I want to go from, let's say 0 to 2 pi again. But I want to make every mark at pi over 8. You know, that's going to be way busy, but let's just do it to see what it looks like. Let's go from 0 to 2 pi. And make every mark. I can literally type in pi divided by 8. Let's see what that looks like on our screen. It's not as bad as I thought it was going to be. In fact, in a funny way, it looks exactly like our graph paper, thanks to those lines. Now, do you notice that I only drew one period in the middle here on my paper? But now I can fill in the rest of the dots. I want to make it look exactly like this image. Let me fill in the rest of the dots, then we'll compare. The book problem seemed to stop just before, just after 3 pi over 2. But I'll go on to 2 pi here. Smooth round, darken it up when you're happy with it. Nice and symmetrical. And then likewise here, following those dots, smooth and round. And then I'll go up 1/3 and a half up, and then 1/3 and nearly at the top. I won't reach the top until minus pi over 8 on the other side. That's interesting. Do you see that you reach the top at minus pi over 8? Now in the book problem, XYZ homework problem, they did not give us that side of it. But apparently I could have also graphed this as +3 cosine 2 times x plus pi over 8. When you say, 2 times x plus pi over 8, you're saying that you're subtracting minus pi over 8 from the x. You're saying that the minus pi over 8 is your starting point. Let me show you that on the graph. So first of all, now that I finished sketching this in, this looks exactly like what's on my screen. Even down to the grid, if I started at minus pi over 8. So let's start this at minus pi divided by 8. Graph. Now it looks exactly like my paper. But this gives me a great idea. Why don't, instead of an upside down cosine graph, why don't I do 3 cosine 2x plus pi over 4. If I multiply this out, 2x plus pi over 4. So let me type that into the calculator, 2x plus pi over 4 there, and see what that looks like. I'm going to say positive 3 cosine 2x plus pi divided by 4. And I'm going to make this one blue just so it overwrites that red one. Light blue, navy blue, I guess it doesn't matter. There's a straight blue. Got it, graph. Look at that blue curve is writing right on top of the red curve. So you have freedom where you start and stop the graph, but that changes when you start the place at a different, when you start the graph at a different place, that might change the other things on the graph. Like here, I'm starting at minus pi over 8. So this minus 3 became a positive 3. Okay, a lot of graphing questions, but that's not bad because I want you to draw perfect graphs. And I did make a lot of comments on some of your graphs, so it's good to practice that some more. We got time for a couple other questions too. And by the way, so when we come back on Wednesday, you will have the test in your hand. You'll be working on it. You know, you can just work on it. You don't have to come to the class session. You can just be working on the test. That's fine with me. But of course, I'm not going to answer any questions on the test. Now, if you're looking at the test and you see similar problems in the book, I don't mind doing similar problems in the book, but I won't just show you how to do the test questions. That's for you to do. So come back and ask some more questions on Wednesday. That would be great, but you got to prep them ahead of time. You know, take problems out of the book that you want to practice that are like the questions on the test. That's fine with me. Okay, I'm just using the test and using your written homework to just slowly help you learn how to write really nice answers. In a way, that's my goal on the written homework and the test. When we're writing on the paper here in class, I guess I'm scribbling a little too fast sometimes. So you can look at the answers I post to the homework solutions. Those are generally written really nicely and neatly. Okay. But you could push in a couple more questions today if you like. What else would you like to look at? I'm just going to organize these and number them so I can scan them after class is over in case you want to check these papers out again. So I'll keep those neatly numbered there. 4653, no problem. Okay, very good. That's a very good question. So I'll show it to everybody. This is very short. I could write it down. It says evaluate without using a calculator. Now, the fact is I could just type it into the calculator as it's written because the calculator can do inverse trig functions too. But if they want me to evaluate it without using a calculator, what do they want? What do they want me to show? What kind of work can I show? So the first thing I'm going to do is read this in English because that tells me what I'm supposed to do. In English, this problem says, and learn how to read this. What is the cosine of the angle whose tangent is 3/4? This is tan inverse. It's going backwards. It's not asking you for the tangent of an angle. It's asking you what angle has a tangent of 3/4. So this thing right here, tan inverse 3/4, that is the angle that has a tangent of 3/4. Just this part right here, if you translate that into English, it says the angle whose tangent is 3/4. Now remember, there's more than one angle that has a tangent of 3/4. So they must be asking for the principal angle, the famous angle, the angle in the correct quadrant. So now, after you say that, what does the whole question say? What is the cosine of the angle whose tangent is 3/4? If you learn to say it like that, you can almost have the problem do itself. So what do I need to draw? I need to draw an angle that has a tangent of 3/4. Make a sketch. Always begin a problem like this by making a sketch. Now, what is tangent? Tangent is what? Opposite over hypotenuse. So I want an angle that has opposite side of 3 to hypotenuse of, no, not opposite over hypotenuse, I must be crazy. Opposite over adjacent. That's tangent, opposite over adjacent. So I want something that has an opposite side that's 3 units long and an adjacent side that's 4 units long. Now, as it is, I can draw that exactly on this piece of paper. But if I have to eyeball it, that's okay too. Here's an angle that has, let me choose a different color, opposite side or adjacent side 4 and opposite side 3. And just as I've drawn it, this angle has a tangent of 3/4. But remember, you can say it like this. Theta is the angle whose tangent is 3/4. Now there's another angle that has a tangent of 3/4 back here. I could have said go down 3 and go back 4 because that angle also has opposite to adjacent ratio of positive 3/4. But remember where tan inverse is taken from? Tan inverse is always taken from minus pi over 2 to pi over 2. And that's on your formula sheet, minus 90 degrees to 90 degrees. In other words, tan inverse is always an angle on the right-hand side here. Okay, so now let's finish the question. What is the cosine of that angle I just drew? What's cosine? Cosine is adjacent over hypotenuse. So I just need to know the hypotenuse here. Now this is a pretty mellow triangle because if I want to know this hypotenuse, if I want to know the radius right here, the r, I just say r squared equals 3 squared plus 4 squared. But that's 9 plus 16, which is a very sweet r squared. R squared is 25. R is 5. Remember the hypotenuse, the radius is never negative. Don't say plus or minus 5. The adjacent side could be plus or minus. The opposite side could be plus or minus. But the radius is always positive number. So now I know that this right here is a 5. And I can just read the cosine. So say the question to yourself entirely again in English. What is the cosine of the angle whose tangent is 3/4? Here's the angle whose tangent is 3/4. What is its cosine? 4/5. So now we're ready for the answer. 4/5. Now I have absolutely no problem if you want to check that in the calculator. And you could type it in exactly as they typed it in. We'll go back to the home screen and type cosine of tan inverse. Tan inverse is over here, a little bit past the division key, above the tangent key. What do I call that? 5th row, 4th button. Tan inverse, 3 divided by 4. And the calculator says 0.8. 0.8 is 4/5. Remember, I might have shown you this before. On the math key, you can make anything into a fraction if it's possible. Just type math convert to fraction. If it can be converted to a fraction, the calculator will do it. So the calculator does acknowledge that that's 4/5. Let me bring that closer to you. So this is why if this question was on the test and you just write 4/5, you got 0 points. Because the instructions are going to say, show me how to evaluate this without a calculator. You say, oh, I memorized the answer. No, not really. So if someone asks you a question like this, they want you to draw this picture. Let me see if I can show it to you like that. See, in the book, this is how he did it. Here's a problem that's similar. In fact, it's very similar. Evaluate the sine of the angle whose tangent is 3/4. So first they drew right here an angle whose tangent was 3/4. Then they worked out that this other side was 5, just like we did. And then they said, what's the sine? Must be 3/5. So whenever someone's asking you a question like this, they want you to draw a triangle to illustrate what they're asking for. But no problem if you want to check it with your calculator. This is the work you'd have to produce on your paper. Okay, toss in, no problem. Any last question you want to ask? You can come back Wednesday. You can ask more questions, all you want. You can key them to the test, but they can't be the test questions. But you can hunt through the book and pick out similar problems. I'll hang out here for, till 1:55. So if you guys are just paging through the book or something, just if you have another question, just shoot it out. Yes, tomorrow by 11:59, as soon as you hand in your homework, let me make sure, because some people came in a little bit past our starting place. Let me show you exactly where that is. Yeah, I keep closing windows. Let me show you exactly where that is on our website. Backwards, backwards, backwards. No, I didn't want to do that. Let's go to our website. Okay, website, Math 121, week 9. It's going to be right here. I'm just going to highlight that right there. I'll turn that into a link, and the link will take you to the exam. Right now, I have a link here just showing you the cover page, just the rules that we're using for the exam. And the cover page is part of the exam. So I do want you to sign and include that with your exam. And if you don't have a printer, you're going to write out that cover page. Math 121, week 9, exam 1. There is the cover page. So right now, this is just the page I want you to look at. Okay. Okay, is there any other questions you want to ask before we hang it up today? I'm just trying to find my way over here. So I make sure I have that for you on our site. Okay, what am I doing? Stop sharing. Okay, good. If you come up with another question between now and Wednesday, just shoot me an email, but I'll put this video online, and then I will copy the pages we wrote, and you guys can just go back to your practice. So you guys have a nice day, and I'll see you later.